Welcome to 8.6, Solving Rational Equations and Inequalities. In this video, we're only going to go over the equations portion. The inequalities part we will talk about in class. What prior knowledge you'll need. We'll be able to solve equations and inequalities. You'll also want to be able to be sure that you can check to see if your value is a solution. We do this by finding the x value or the variable value and we plug it back into our original equation to ensure that it works. And the last part is all these problems are going to have fractions in them, but we can quickly get rid of them if we multiply by the least common denominator to eliminate the fractions. Always attempt to multiply both sides by a value that eliminate the fractions, even if you do it step by step. So here's what the type of problem will look like. You'll be given several fractions, and we're going to just be looking at the bottoms because we do want to get rid of these bottoms as soon as possible. Now the first thing we want to consider here is what can we multiply to get rid of one or more, maybe all of the fractions. The first thing I'm going to do is I'm just going to look at these numbers, 28 and 4. If I multiply both sides by 28, then multiplying this first term by 28 gives me 9 because the 28 over 1 cancels out. And then multiplying the second term by 28, I get 28 times 3 on top, and z plus 2 is still on the bottom. And then over here, I multiplied by 28 over 1, so I have 3 times 28, and then that's all over 4. Okay, at this point, I can cancel these out, and this becomes 21 on the right side. And now I'm just going to go ahead and rewrite this. And doing some quick simplification, here's what I have. At this point, we really want to be careful when we look at the equations and ask ourselves, how can we make life easy? So here in this case, if I subtracted 9 from both sides, then I would end up with this. Now this makes a life a lot easier. At this point, since this bottom is z plus 2, I can multiply both sides by z plus 2. This effectively cancels out, and I'm left with 84 is equal to 12z plus 24. And now if I subtract 24 from both sides and divide by 12, I get z is equal to 5. A couple of things to point out here. The route that I took is one way to solve this. There are multiple other ways to do it. If at the very beginning you multiply by 28 and z plus 2, that's also a way to get rid of all the fractions very quickly. I would encourage you to eliminate one fraction at a time though, 1 or 2. So notice 28 and 4, I could get rid of 2 at the same time because they're both numbers. Be very careful with your operations. Make sure that you multiply the entire side by the number or like the z plus 2. So make sure it gets distributed in, and make sure that you cancel correctly. If you make a minor mistake, it's going to throw off your entire problem. So you want to work through these with care. The second part that we're going to do is we're going to check it to make sure that we have done it correctly. So what we're going to do is we're going to check that our solution 5 is the correct one. So what I'm going to do is I'm going to go back to my original equation, and just like in Algebra 1, I'm going to plug in 5, and now I have 9 over 28 plus 3 over 7 is equal to 3 over 4. If I scale this portion up, I could rewrite it as 12 over 28, making those equivalent fractions, and I'd end up with 21 over 28 is equal to 3/4. And if I divide both of these by 7, then I could see that 3/4 does in fact equal 3/4. So our check step is just plugging that original value back in to ensure that it makes a true statement. Example 2, I'm going to take a little different route on. What I'm going to do is I'm going to start off by finding the least common denominator. Now the least common denominator is based off of these bottoms, so 6 and 2, the lowest number that both of these go into is 6, and then there is also an x minus 6. what I'm going to do is I'm going to multiply both sides by this least common denominator. And this is essentially what we did in the first example, except in the first example we did it step by step. Here we're going to do it all at once. So multiplying this by the first set, the 6's go away, and we're left with 5 times x minus 6. When we multiply it by the second part, the x minus 6's would go away, and we're left with 6 times 2. And then on the right side, that's equal to 6 over 2, and it's times x minus 6. So all I did was I just multiplied these two together, and I kept the x minus 6 there. I'm going to do a little bit of distributing here with the distributive property. Plus 12. 6 over 2 is 3, so 3 going in here. We have 3x minus 18. And now it turns into an Algebra 1 problem where we're trying to get all of our x's on one side, all of our numbers on the other side. So subtracting 3x from both sides, we get 2x. I'm just going to combine these two pieces and make it minus 18. And that's equal to negative 18. Adding 18 to both sides, I get 2x is equal to 0, and x is equal to 0. Looking back at this, if I multiply by the least common denominator, which I found, it gets rid of each fraction. And then I'm left with something that is very easy to solve. I encourage you to either be fluid with this method, or consider the method I used before and multiply by certain things for each step and write out a few extra steps, but ensure that you did it correctly. So I think that both are important to consider, and the place that you're going to make the most mistakes is on this distribute. Okay, so when you distribute it in, make sure that it goes to everything and that you've canceled things correctly. Checking the solution, I'm going to plug 0 in. So I have 0 minus 6. 5, 6 plus 2 over negative 6 is equal to 1/2. So this is really like 5, 6 minus 2, 6, which is 3, 6. And 3, 6 does in fact equal 1/2, so we know that our solution is correct. Example 3 is going to be much like the other examples. The only difference here is we have r squared minus 1. So instead of writing that, I'm going to write r minus 1, r plus 1, which is the factored form. Remember, this bottom over here is 1, and this one is r plus 1. So here, definitely consider multiplying things one at a time on this problem. So here, I just want to get rid of this r plus 1, so I'm going to multiply by it, and I'm going to multiply the entire left side by r plus 1 as well. And when I do so, my first term becomes r times r plus 1. That's where it goes right here. And then it's plus, and it's r plus 1 times r squared minus 5. That's on top. And then on the bottom, it's r minus 1, r plus 1. So naturally, these two can cancel out. And on my right side, the entire reason why we multiplied by r plus 1 was to get rid of this fraction. So on our right side, I am just left with this top. Now I'm going to do a little distributing here and get r squared plus r for this portion. And then it's going to be plus, the top just is still r squared minus 5 all over r minus 1. And these problems are difficult. So we have to make sure that our attention to detail is definitely elevated on these types of problems. Now, getting rid of the second fraction that we see, this r minus 1, we're going to multiply both sides by r minus 1. By multiplying it by r minus 1, we can effectively get rid of the fraction. So what happens here is I'm actually going to take this portion and rewrite it as r plus 1 times r. and you'll see why here in a second. It's multiplied by r minus 1, and then that's plus, and when you multiply these two pieces here, you are left with r squared minus 5. And then when you FOIL this out, you distribute it out, so each piece here goes to every piece over here. You get r to the third minus r squared plus r squared minus r plus 2r minus 2. And that was me just doing this to every single term. So it's just a little extension. Now the reason that I took this and I left it as r times r plus 1 is since this is multiplication, I can do it in any order, and it's just going to save me a step here. If you didn't do that, then you'll end up taking r minus 1 times each of these terms, which is no big deal. So here we have r plus 1 times r minus 1, which is r squared minus 1, and that's times r. And then we have plus r squared minus 5, to this addition of this. And then on the right side, I'm going to have to simplify here. I end up with r to the third, and then these two pieces cancel out. I'm left with a positive r and a minus 2. Now distributing this r in, I get r to the third minus r plus r squared minus 5, and everything on the right side I'm going to keep the same. So on this problem, I'm essentially going to try to combine things and get everything to one side. If I subtract r squared from both sides here, these two pieces go away. I still have an r squared over here. If I subtract an r from both sides, then I get r squared minus 2r minus 5, and that's equal to negative 2. And I add 2 to both sides, so I end up with r squared minus 2r minus 3 is equal to 0. Now we have to factor. So when we factor, we end up getting r minus 3 and r plus 1. So we know that r is equal to 3 and r is equal to negative 1. At this point, we want to plug both of these values back in to check. I will allow you to do that on your own, and please bring that into class to show. So our key steps: we always want to multiply by something to get rid of a fraction or multiple fractions. If there's something that can be factored, we want to do so. Here, our LCD of our bottom was r minus 1, r plus 1. We multiplied by r plus 1 first, then we multiplied by r minus 1 down here. So we multiplied by both things in the LCD in order to get rid of them. Again, you can do this at the very start and multiply by both things, or you can take it one step at a time and say, how can I get rid of one fraction, and then move on to our new problem and say, how can I get rid of the other fractions, and solve. And you'll always want to plug these back in to ensure that they're correct. We'll do the solving rational inequalities in class, so be prepared for that. It's going to be very similar to what we just did, so as long as you can do those and the additional problems, you'll be just fine. I want you to go ahead and complete the additional problems and plug them into the Google form right below this video. And if you're having difficulty with these problems, please come see me in ACLAB or as soon as possible so that we can fill in these gaps and you'll be ready for class. Thank you.